mole concept. First of all, I want to give you two terms. One is gram atomic mass. Gram atomic mass. The gram atomic mass of an element is mass of 1 mole of atoms of that particular element. To say simply, it's numerically equivalent to the atomic mass expressed in grams. For example, consider atomic mass of oxygen. Atomic mass of oxygen's atomic mass is 16 units, because the proton number is 8, means the atomic number of oxygen is 8. So the sum of proton number and neutron number. So 8 plus 8, which is equals to 16. If this 16 units is expressed in grams, then this is called gram atomic mass of oxygen. Gram atomic mass of oxygen. In similar way, if you take hydrogen atom, just 1 unit, so it should be 1 gram. This is called gram atomic mass. Consider chlorine is 17, so this is 17 plus 17. You know well, if the atomic number is odd, then you have to add 1 to this, so it will be 35. Actually it is 35.5. Let us consider it is 35. So the gram atomic mass of chlorine is just 35 grams. Gram molecular mass, this is nothing but expressing the molecular mass in grams. For example, if you take oxygen molecule, which is O2, which is equals to 2 into O, which is equals to 2 into 16, which is equals to 32. If it is expressed in grams, then it is gram molecular mass. In similar way, if you consider hydrogen, this will be 2 into H, which is equals to 2 into 1, which is equals to 2 gram. If you take H2O, this is 2 into H plus 1 into O. 2 plus oxygen atom, so it is 16, so it is 18 grams. If you consider NaCl, sodium chloride, sodium is 23 plus chlorine is 35.5, leave 0.5, so it is equals to 58 grams. Take CO2, which is equals to carbon plus 2 oxygens. Carbon is 12 plus 2 oxygens is 32, which is equals to 44 grams. These are called the gram molecular masses. 1 mole is exactly 6.022 into 10 power 23 elementary entities. Those elementary entities may be atoms, molecules, ions, or any type of particles. These are equivalent to the number of atoms in 12 grams of carbon 12. In 12 grams of carbon 12, the number of particles will be 6.022 into 10 power 23. So this is taken as a mole. Roughly, we can write it as 6.022 into 10 power 23, and this number is Avogadro number. If you take any mole, that mole should contain this much. Means 1 mole of oxygen is 32 grams and 1 mole of hydrogen is 2 grams. 1 mole of water is 18 grams and 1 mole of sodium chloride NaCl is 58 grams. So all these and so on, all these should contain 6.022 into 10 power 23 particles, and those particles are molecules here, because we took gram molecular mass here. So it contains 6.022 into 10 power 23 molecules. So don't get confused how it is 32 grams and 2 grams, 18 grams, 58 grams. All contains the same. Let us take one example of daily life. 1 dozen of eggs is nothing but 12 eggs. 1 dozen apple, 12 apples. 1 dozen pencils, 12 pencils. All are 1 dozen, but the things are different, but the number is same. Like as dozen represents a number, here the mole represents a number which is 6.022 into 10 power 23. By this you can understand any mole of a substance have 6.022 into 10 power 23, maybe atoms, maybe molecules, maybe ions. If you consider gram atomic mass, then this will be atoms. For example, consider the gram atomic mass of oxygen, which is 16 grams. This 16 grams of oxygen contain 6.022 into 10 power 23 atoms. Similarly, 1 gram of hydrogen contains the same number. But if you take these two are gram atomic masses. If you consider gram molecular mass, then molecular mass of oxygen is 32 gram and molecular mass of hydrogen is 2 gram, and these two also contain 6.022 into 10 power 23. But here the particles are molecules. Here the particles are atoms. That is the difference. At STP, 1 mole of any gas, maybe oxygen, hydrogen, carbon dioxide, chlorine, whatever it may be, 1 mole of any gas occupies 22.4 liters of volume. Means 32 grams of oxygen or 2 grams of hydrogen or 44 grams of carbon dioxide or 35.5 grams of chlorine. All these gases occupies 22.4 liters. The standard temperature and pressure. The standard temperature is 0 degrees Celsius or 273 Kelvin, and standard pressure is 1 atmospheric pressure or 760 millimeters of mercury, or this is 760 torr. And at this temperature and pressure, 1 mole of any gas occupies 22.4 liters of volume. This is the question given here. The number of grams of H2SO4 present in 0.25 mole of H2SO4. So here you have a formula. Number of moles is equals given mass by GMM. First of all, you have to find out the gram molecular mass of H2SO4. So gram molecular mass of H2SO4 is, so what are the atoms present here? 2 atoms of hydrogen, 1 atom of sulfur and 4 atoms of oxygen is equals 2 into hydrogen is 1 and sulfur is 32 plus oxygen is 16. So 2 plus 32 plus 64, which is equals to 98 grams, and given the number of moles as is equals to just 0.25. If you substitute these things here, you will get 0.25 is equals to the mass required. We have to find out. Let us consider it as x by gram molecular mass, it is 98, implies x is equals to 98 into 0.25, which is equals to 24.5 gram. 24.5 grams of H2SO4 present in 0.25 moles. Here one question is given, find the number of atoms present in 19.7 kg of gold. For this you can use this formula, number of atoms is equal to given mass, that is 19.7 kg by gram atomic mass, or you can take gram molecular mass also, because gold is monoatomic. For monoatomic elements you can take gram atomic mass or gram molecular mass into 6.022 into 10 power 23, which is called the Avogadro number. Now gram atomic mass of gold is 197 grams. The mass given is 19.7 kg. So you have to find out the number of atoms in 19.7 kg. This is given mass, and this should be converted to grams. So it is 19.7 kg, kilogram, kilo means 10 power 3 grams. You know well that 197 grams of gold contain 6.022 into 10 power 23 atoms. You can use this formula, or directly you can do like this. And what's about 19.7 into 10 power 3 grams of gold contains? How many number of atoms are there in 19.7 into 10 power 3 grams of gold? For this I am going to do like this, 19.7 into 10 power 3 by 197 into 6.022 into 10 power 23. So it can be written as 197, and point moves, because the point is removed, it will become 10 power 2, 10 power 2 into 10 power 23. So it is 6.022 remains like that, and it is 10 power 25, because here 2 and 23 total becomes 25 by 197. So you can remove these two, and finally the number of atoms is equals to number of atoms in 19.7 kg of gold is 6.022 into 10 power 25. One more question is here, the number of moles of hydrogen gas in 0.224 liters of hydrogen gas at STP. 1 mole of hydrogen gas occupies 22.4 liters. So how much moles, how many moles occupy 0.224 liters? This is the formula you can use, or you can write 0.224. This is the given volume, and 22.4 liters is the volume that can be occupied by 1 mole of hydrogen, is equals to, so this can be made easy by moving the point to this place. To move that to that place, this can be written as 22.4 into 10 power minus 2 by 22.4. This gets cancelled. You will get 10 power minus 2. 10 power minus 2 is nothing but 0.01 moles. Means 0.01 moles of hydrogen occupies 0.224 liters of volume at STP.